we're going to review an exponent rule that you talked about last year, and that is when you are multiplying powers with the same base, you add the exponents. Okay? So if I have x squared times x to the fifth, I'm multiplying right there. These are the same base, so I add the exponents. This is x to the 2 plus 5, which becomes x to the 7th. Notice the base does not change. You are not normally going to show this step. You're going to go straight from here to here, and that's okay. All right? So x to the 6th times x to the 3rd would be x to the 6th plus 3, which is x to the 9th. And if I have a times a to the 5th, remember if there's not an exponent, there's an understood 1 there, so that would be a to the 1 plus 5, which is a to the 6th. Again, you're going to get to skip this middle step. You don't have to show that. You can go from here to here. Now, what can we do with that? Let's look at a problem like this. If I have 2x cubed times 4x to the 4th, okay? Notice this is all multiplication. This is 2 times x to the 3rd times 4 times x to the 4th. Multiplication is commutative. It can be done in any order. So I can regroup this. I'm going to put my two numbers together, 2 times 4. I'm going to put my two variables together, x cubed times x to the 4th. Then I can multiply my two numbers. 2 times 4 is 8. And then x cubed times x to the 4th, I'm multiplying with the same base, so I'm going to add the exponents. So 2x cubed times 4x to the 4th, that is not x to the 4th, that should be x to the 7th. 3 plus 4 is 7. Okay? So when you have something like this, you're going to group your numbers, group your variables, use your exponent rule. This next problem is very similar to that. It looks scary, but it's really not. Let's say I have 10 x squared y over 3 times 6 x cubed y squared over 5. Okay? Again, when you look here, we have numbers, we have variables. Group like things together. So we're going to put the 10 thirds, that's a fraction, times 6 fifths. This is just a fraction right here, 10 over 3, 6 over 5. We're going to put those together. We're going to put our x's together, x squared, x cubed, and we're going to put our y's together, y squared. Now, look at your fractions, multiplying fractions. This is pretty simple because things cancel. I end up with 2 times 2, which is 4. Then I have x squared times x cubed, which is x to the 5th, and y times y squared, there's a 1 there, I get y cubed. One more type of problem we want to look at with this section. 2x cubed times negative 4x squared plus 5x squared times 3x cubed. Now, since we have this addition here, we have to look at this multiplication and this multiplication. We have to multiply before we add because of the order of operations. So over here, I'm going to group the 2 times the negative 4 and the x cubed and x squared. Then I have plus. I'm going to group the 5 and the 3 and the x squared and the x cubed. So I look, 2 times negative 4 is negative 8, x to the 5th, plus 5 times 3 is 15, x to the 5th. Now I'm adding, these are like terms, right? They both have x to the 5th, so I can combine them. If these weren't like terms, I'd be done. Couldn't do anything. But since they're like terms, Negative 8 plus 15 is 7. X to the 5th. You can only do that because these are like terms. That's important. If they were not like terms, this part right here would be your final answer. This only happens because they were both x to the 5th.